supposed to be like the greatest wrestler? He lost.
No, that's Gavin's
Sometimes people do that.
Oh,
Okay.
maybe he's not allowed to.
So next little wrinkle in nomenclature. So we started off doing simple metals and nonmetals: sodium chloride, potassium fluoride, magnesium oxide. Then we added polyatomics: sodium sulfate, ammonium chloride, calcium carbonate. Okay. Today we're going to talk about how do we tell a reader what D block metal you're using if you have a D block metal. So I have a whole bunch of iron oxides. I actually have 3 iron oxides in the back room. One's red, one's black, and one's gray. And if I just said, go get some iron oxide, you'd be like, which one? Well, they all have different formulas. One of them is this, FeO. One of them is Fe2O3, and one of them is Fe3O4. So these are all iron oxides. So what we have to do is we have to add a Roman numeral to say, this is the charge of that D block metal. Remember, D block metals are multivalent. They can be 0 as elements, and 1 through 7 when they're cations. But you have to use a Roman numeral to say what it is. So let's just quickly review what our Roman numerals are.
1,
2, 3.
Oh, I don't know. It's getting
This is getting, I need a better red. You know, let's just use blue. Let's do it again in blue. Okay, here we go. 1, 2, 3. How do you make a 4? IV.
V.
5,
V-I.
6, and finally 7. And for posterity, 50, 100, 1,000. Oh, there's one more missed one. D. 500. 1,000. Okay. So we use Roman numerals to show the compound's charge, and sometimes you see it in parentheses. Don't use parentheses. Okay. Sometimes you'll see the Roman numeral in parentheses. Don't use parentheses because a 1 in parentheses looks a lot like a 3. And I wish people would stop doing that, but you still see it every now and then. They put it in parentheses. No, don't do that. Anyway, so iron 3 oxide means you're dealing with an iron that has a 3 charge and an oxygen that has a 2 charge. Which of those 3 is iron 3 oxide? Fe2O3. Fe2O3 is iron 3 oxide because this iron is +3 and +3, and this oxygen is -2, -2, -2. +6 and -6 gives you an overall oxidation of 0. So far, so good?
Wait, so this is for the name of the element?
This is when naming elements out of a D block metal.
Okay.
So you have a D block metal and a few of the heavier P block metals. They are multivalent, so you have to tell the reader, this is the metal that I'm using. I'm not using iron 1, I'm using iron 3. Similarly, chromium 6 nitride. You have a chromium, which is Cr, it's +6. You have a nitrogen, which is -3. So chromium 6 nitride is CrN2. Comprende? All right.
So would that make the Fe3O4 iron oxide iron 4 oxide?
This one down here?
Yeah.
Yes. No. This one's a little wonky because oxygen is -2 and you can't do a 3/8. This one's a little wonky. It actually, we pretend it doesn't exist even though it's one of the most common. This one's +2 though.
Okay.
I'm going to try to shield you from most exceptions. So iron 2, Cobalt 3. Tin 4. Chromium 6. Yeah? All right. The biggest trap with Roman numerals is you see a number and you think that's how many of something it is. It's not. It is the charge. Looks.
Wouldn't the 1 kind of look like an iodine? Like an iodine element?
Yeah. Make it really big.
Just be smarter than that.
Yeah.
Okay.
And we're also writing it out too. Okay, so the biggest trap when you're using Roman numerals is you look at it and say, oh, I see a 3. That must mean there's 3 irons. It doesn't. It means there's a charge of each iron. Also, you don't use Roman numerals in formulas. You only use them in names. Because formulas, when you put it together and you get a 0, they're kind of taken care of. Questions?
You said we don't use them? We don't use Roman numerals?
Formulas. So you don't use Roman numerals here. You use Roman numerals in the name. So you would name this iron 3 oxide. So that doesn't tell you there's 3 irons. It tells you each iron is plus 3.
Is that how you say it? Like you say one
You say
and one
tri-
still?
You say iron 3 oxide, iron 1 oxide, chromium 6 nitrate. All right. Other questions?
Would you use them if it's a negative charge or not?
Metals can't be negative.
Oh.
Metals will always be positive. Good question. Others? So this is copper 2 chloride. Can you see why it's copper 2 chloride?
Yeah.
Because, yeah. So each chlorine is -1. So -1, -1. That makes the copper +2. Copper 2 chloride. Yes.
So you'll only have like P block elements with the D block metal.
Yes.
Okay.
Or polyatomic.
Or okay.
Can you see how this is titanium 4 oxide?
Yeah. Because the oxygen is -2.
-2, -2. That makes it titanium +4. This is vanadium 3 oxide. Convince yourself that that's vanadium 3 oxide.
Yeah.
Why?
Because it's close to
Okay.
iron.
Is it because each vanadium has a free charge?
Yep.
Oh.
There's 3 oxygens, -1, -1, or sorry, -2, -2, -2, for a grand total of -6, which means the positive side has to be +6, and there are 2 metals to make up the +6. All right. Let's pause for a second. If you have any questions, yes.
Why couldn't the vanadium just be like 6 electrons? Like why is it 3?
Because we want to say the charge of each metal. Otherwise, it would go off the rails if you had like multiple, like if you had 3 + 6 metals, it would be like 18. That would be like a mass. It would just be a mess.
Oh, okay.
So we only want to say the charge of the individual metal, each metal. And then we use arithmetic after that. Other questions? Okie dokie. Practice, practice, practice. What is that?
NiCl3.
Well, obviously it's an NiCl3. But what is the name of this thing?
Nitrogen chloride.
Why don't you go ahead and write it on your piece of paper or scratch paper on your arm, your desk, whatever. Once you have an answer, see if your neighbor agrees with you.
Oh wait.
Well, that's
But it's
Is that right?
Okay, so each chlorine is -1. That makes your nickel +3. How do you feel about nickel 3 chloride?
Yes.
All right. How about this one?
Zinc. The NO is nitrate.
So there's
No.
wait, isn't that one where zinc to negative one? There's two negative ones. Yeah, zinc to nitrate.
Don't have the name.
So yeah, so nitrate, NO3, has a -1 charge. There's 2 of them. That forces your zinc to be +2. So how do you feel about zinc to nitrate?
Yes. Good.
Questions so far?
Oh, wait, hold on.
Yes, waiting, hold on.
Oh, wait, it's just because it's nitrate. Never mind.
Next. What's that?
Cobalt.
Cobalt 6 bromide.
You smell.
Yeah, I've been sweating.
Hurt.
It's an ene. Chlorine, chlorine, bromine, iodine. It's an ene. So it's between chlorine and iodine.
Oh, he's still.
One.
I get a negative 6. No, he did smell.
So is it some?
Cobalt.
Yep. That's last year.
Oh my god. There's 6 of those?
How do you feel about cobalt 6 bromide? Good.
Wait, can you explain that one, please?
Yes, of course. I can explain them all. So we know bromine in the negative position is in group 17, so it's -1 each. So there are 6 -1s. But there's only a single metal to cancel out the entire -6. So that one metal must be +6. Other questions? Una más? What is that?
Iron something.
That one. Oh, that's iron.
What's that one?
Hey, iron trioxide.
Iron trioxide. Lowest common multiple of 2 and 3 is 6. What is that?
Sodium.
Sodium. Sodium phosphate. Negative. Sodium.
But it's very important to put it there.
-3. Yeah. And there's 4. Oh no, PS4 is just minus 3.
Oh wait, sodium 1. Sodium 1.
Yeah, sodium nitrate.
No, yes. Do you have to say the 1 or no?
He's trying to trick us. Sodium nitrate.
So what's the answer to Shane's question? You have to say a 1?
No.
No, you don't. Because there is no D-block metal in that
I'm
chemical.
sorry.
It's just plain old sodium phosphate. That's why I put it there. I was just using context clues.
Oh, it's because there's no metal. Bro.
Because sodium is not a D-block metal.
Oh man.
+1 metals are always +1. +2 metals are always +2. Okay. If you have any more questions about this system, let me know. If you're comfortable and ready to go back go back the other way, give me a thumbs up. Okay. Now we're going to use some names and write some formulas.
No, I don't.
Remember, the overall oxidation of each compound must be 0.
Wait, nitrate or nitride?
What's it say?
That just means. Nitride is just like Oh, it's totally its own.
It'll be S.
Nitride.
No,
You're just writing that.
Bro, I swear these things don't even.
It would be like
Nitrogen is group 15.
So we just need to write them.
That is correct.
Scandium, one scandium on one.
How do you feel about SCN? Plus 3, minus 3?
Yeah.
Just need one of each? Okay, if you can see why it's just SCN, give me a thumbs up. If any part of this is unclear, wave your hand around so I can explain. Okay, so don't play video games while I'm talking. Pay attention to everything we do. Scandium is a D block metal. The 3 after scandium tells us that D block metal has a plus 3 charge. Nitride is the suffix for nitrogen. So don't be careful with nitride and nitrate. Nitride is a suffix for nitrogen, which is in group 15, and therefore has a negative 3 charge. Plus 3, negative 3, one of each. Next.
Copper, sulfate, sulfate.
Yeah. Copper has a charge too.
It's just one. Copper. Sulfate is -2.
CU.
Yeah.
Dude, I keep forgetting that.
Oh, it's not just sulfur.
Oh, it's so fake.
Sulfate. So it's SO4 2.
This would be a good time to mention, just like you don't show Roman numerals in a formula, you also don't show the charges in a formula. If you want to put the charges above the chemical, kind of like keep track of things, that's fine, but do not put them in the chemical. The only thing that should be in a chemical formula is the symbols and the subscripts. That's it.
So yeah, SO4.
What's that?
What is carbonate? Carbonate is -2 C. So AG carbon CO.
That's alphabetical. It's alphabetical by their family. So carbonate, bicarbonate, the same thing. Perchlorate, chlorate, chloride, but the same thing.
Carbonate -2.
Wait, I don't see how it's.
Actually, you know, it's not alphabetical. I originally wrote it alphabetical. I don't know why it's in that order now.
Some of them are together and it's like all the M's are together.
I should rearrange it by charge or by alphabet. Maybe another time. Okay, so silver indicates it's a +1 charge, and carbonate's -2. So how do you feel about AG2CO3?
All right.
Questions? What's that?
One second, let me look at that.
1 second.
Yeah, why is the silver, why is there 1 in front of the silver if there's 2? Oh, wait. No, wait, iron.
Got it? All right.
So the one is the charge.
I do know.
Last one.
I do know stuff.
Cadmium, or
Titanium.
Acetate C2H3O2. Oh, it's TiC2H3O parentheses 4.
What is titanium?
It's like
I don't know. I can't use that.
C2H3
alcohol.
Is it TI? What else is TI? What's that much?
All right. So acetate's the giant, or the giant polyatomic C2H3O2. Titanium 4 acetates -1 each. So how do you feel about Ti quantity C2H3O2 quantity 4? All right. If you have any questions about this, wave your hand around. If you're ready to work on your own, give me a thumbs up. All right, off you go.
We're map testing math, right?
Yeah.
You're map testing when? Oh, in math. Okay, good.
That is so annoying.